Hello, everybody. Harry from GMAT Ninja here, and welcome to the next episode in our GRE Quant series. In today's episode, I'm going to be taking a look at the data interpretation questions in the GRE Quant section. Now, this is a bit of a strange topic because there really isn't any content specific to data interpretation. Today, we're going to be looking at a little bit of basic statistics, a little bit of basic percentages, but really there's nothing specific to data interpretation. This is more about a process. And that's one of the things I want to take a look at today, a process to examine these questions. I've got it written up behind me here. We'll take a look at that in a second. And that's going to be a big part of what we do. It's going to be about how you do the questions, a little bit more than what content you need to know. Part of that's going to be based around estimation and approximation. The question is, what is the smallest amount of work I can do in order to get the answer? I'm not looking for shortcuts because they generally lead to you actually needing to take more work or making a mistake. What I'm looking for is the most efficient route through the problem. Do I really need to calculate 7 different things, or can I do one calculation and then compare them to the data, and that's going to make things quicker? Those are the sorts of questions we're going to be asking today. And then really a lot of this is going to be about how not to beat yourself. Lots of the time in data interpretation questions, it's about very precise reading of graphs or reading of tables, and people are trying to rush. And by rushing, they misread things and they miss questions that really aren't that hard. Data interpretation questions aren't actually that difficult. It's just people make them difficult by making themselves feel under time pressure and wanting to get through them quickly. So as I said, I'm going to be looking for efficiency in everything we do so that we can do the least amount of work possible. We can feel like we've got enough time to work through the questions, and that's going to allow us to be as accurate as we possibly can. All right, so the process that I'd like you to think about following, if we think of these questions, these data interpretation questions, a little bit like a long reading comprehension passage. In the quant section, you're probably going to be doing 3 data interpretation questions in a section, and they're all going to be based off the same table or the same graphs in some respect. So in the same way that we would do with a long reading comprehension passage, we can spend a little bit of time with the data first, and really, please read the data before you read question 1. Quite often when I'm speaking to my students, they almost ignore the data entirely. They just read the question, and then they wonder why they're not really sure where the question's going. So if we think of these questions like a long reading comprehension passage, in those reading comprehension passages, you would take the time to read the passage, really understand what's going on before you get into the questions. So in today's video, I'm going to be giving you 3 sets of data. We're going to be doing 10 questions across 3 different types of, 2 graphs and 1 table. And in the first question, I'm going to give you a bit longer each time so that you can treat them like a reading comprehension passage. You can read the data, really understand what's going on. Then we can reduce the time we spend on each of the later questions. Right, so treat them like a reading comprehension passage, really read the data before question 1, and plot your path each time. Give yourself 10, 15 seconds to really think, is this way that I'm thinking about, is it the most efficient route through the problem? I really want you thinking about efficiency here. These questions can look intimidating. They can look big. You can make it seem like you have to do a lot of work in order to get through, but maybe there's a much quicker, less labor-intensive way of doing the problem. Right, so with that, we're going to get into some of these questions. Now, like I've said earlier, the difficulty rating of these questions is not necessarily that hard in the question itself. It's all about how you treat the data. So first one coming up now, as we said, I'm going to give you a little bit longer on the first question than on the second, third, and fourth question using this same data. Read the graphs, have a look. There are going to be a couple of pie charts. Have a good look at them before you worry about question 1. Probably going to give you a couple of minutes to take a look at this question, and I'll see you back here soon. All right, I'll get the first one up on the screen, give you a chance to have a look at it. See you back here very soon. All right, as usual in these videos, if you need a little more time to have a think about what's going on, now's your chance to pause the video, but we'll still be here when you come back to us. All right, I'm going to keep myself tucked away in the corner for as much as possible when we're doing these questions, certainly to begin with. Because like I said, part of what you need to do in these problems is to plot your path, is to think about the most efficient way through the problem. If we need to do any calculations, I'll make myself bigger so that you can see what's going on. But we can get through an awful lot of these questions without going into the nitty-gritty of lots of calculations here. So first question using this data. So I'm going to spend some time taking a look at the graphs first. Like I said in the introduction. Two graphs, left-hand side is the world distribution of the world population by region in 1900, right-hand side in 2020. Now, first thing to notice is if you look at the totals down at the bottom, the size of the graphs themselves might be just about the same, but the total population they're covering is a little more than 5 times bigger in the right-hand graph than the left-hand graph. So it's not just a case of the percentages changing and the total staying the same, the total changes as well. That's going to be quite important straight away. It's definitely going to come in later questions. Right, so then you've got the various regions and the population the percentage will change as we go from 1900 to 2020. And those interactions are what we're going to have to deal with in these questions. And from that, we can take a look at this question one that asks us how many regions experience a decline in population between 1900 and 2020. Right, so first thing that we can say is since the total population has increased, if the percentage has also increased, then there's no way that population has declined. The percentage has gone up, the total has gone up, so we can definitely say for those regions the population has gone up. So for South America, the Middle East, North America, Africa, and Oceania, the percentage has gone up, the percentage of the world population in their regions has gone up between 1900 and 2020, and the total population of the world's gone up from 1900 to 2020. So there's no way those regions have experienced a decline in population. So we don't need to do any calculations for them. The only regions we have to do any sort of calculation for are going to be Europe and Asia. Right, so let's take a look at Europe first. And again, at this point, we could get the calculator out and get into a lot of detail, but really I can be quite rough here. If I look at 2020, Europe's population is about 10% of something about 8 billion. Again, given the numbers, I don't have to be that accurate here. So Europe's population in 2020 is about 800 million. Go backwards to 1900, 800 million is about 50% of 1.524 billion. It's a little bit more than 50%. So since Europe's population in 1900 was only 15% of 1.5 billion, or that's about 225 million if you want to go in to do the calculation, it's gone up from something like 225 million to 800 million. To 800 million. So Europe's population has gone up. And so I don't need to get the calculator out. I don't need to do a lot of work. I can sort of eyeball it and see where I get to. So we've only got one more to check here. And Asia's population, again, if I look at the 2020 region first, is a little bit more than half of this nearly 8 billion. Or in other words, Asia's population in 2020 is, it's around 4 billion, maybe a little bit less, but around 4 billion. Compare that to 1900, that 4 billion is more than the entire population of the world. So the population of Asia, even though the percentage has gone down, must have gone up. So I know I've tucked myself away in the corner and I haven't really done anything there, or I haven't done any calculation with pen and paper or even the calculator, but that's part of this. If you think about what we've done there, we've managed to change the problem from checking out all the regions, got rid of the ones where the percentage increased. We've sort of estimated or approximated the two where the percentage decreased and found out that none of the regions experienced a decline of the population. So without doing any calculation or without any really precise calculation, I can tell you the answer is A in this question. All right. So I hope that's a bit of an insight into how to make these, or how to be as efficient as possible in these questions. I'm going to get the next question up on the board in a second, up on the screen in a second. And now that you've had a chance to look at the data, I'm hoping that you'll be a little bit quicker through this problem. So I'm going to give you a little bit less time on the next question. I'll see you back here to take another look at the next question soon. Okay, pause here if you want some more time to take a look at this one. I'm actually going to take this question away first so that we can have a talk about the various different ways you might go through this problem and talk about that efficiency thing. So this question's asking us how many of the 7 regions had a population that exceeded the average population for all 7 categories in 1900. So we're looking at that left graph, and I will put the graph back in a second so that we can take a look at the numbers there. But the first thought that lots of people have when they see this question is, well, I can get the total population from 1900 off. That's off the bottom of the graph, 1.524 billion. So there are seven regions, and so the average 1.5 billion divided by 7 gives you 217 million. Right. Then they go on and go, well, I have percentages for all the regions, so I can figure out the population for all those regions. In this case, I've done South America, 2.49% of that 1.5 billion. South America's population is 37,900,000. That's smaller than the average, so South America wouldn't be one of the ones that would exceed the average. All right. So one way of doing it, it'll get you there. It'll take an awfully long time. Right, the pie chart, if you remember back, I'll put it on the screen in a second, but the pie chart was all about percentages. The total, it's 1.5 billion, but I could also say the total just equals 100%. And so the average population, well, 100 divided by 7 is going to give you 14.3%, because the pie chart is all in percentages. So any region that has a percentage greater than 14.3% is going to be bigger than the average. Any region that has a percentage less than 14.3% is going to be below the average. So rather than go through and figure out the actual population for all 7 categories and compare it to the average, which is going to end up being about 8 or 9 calculations, I can do one calculation and then just look at the graph. And as you can see, I'll put the graph back up on the screen here. If the region, again, looking at the left pie chart, 1900 only, if the region has a percentage bigger than 14.3%, then it exceeds the average. So South America does not exceed the average, nor does the Middle East, nor does North America. Europe does exceed the average. Africa does not. Oceania does not. And Asia does. So 2 out of the 7 exceed the average. So our answer here is B. Right, so the reason I came back to the board over here is to show you those 2 different paths, both of them equally valid if we had an unlimited amount of time. But if you think about the information you've been given, that pie chart, both pie charts give you percentages. So I could say, rather than try to figure out the actual number of people that would make up the average, if I just think that the total is 100%, so the average is 14.3%, I can do one calculation and get through the question much more efficiently and use up much less time. So that's what I meant at the start of the video when I said, give yourself 10 seconds, 15 seconds, whatever it is, to think about how you're going to answer the question. It might save you a huge chunk of time later. All right, we're halfway through the questions for this set of data, so I'll get the next one up on the screen. Like we said before, giving you a little less time because you've had a chance to look at the information, and we'll see you back here soon to go through the next one. All right, now's your chance to pause it if you need a little more time on this one, but I'm going to pull the question away again so that we can have a look at how I'm going to approach the problem, and then I'll put the graphs back so that we can finish the problem off. right, so this question, for which of the following regions was their population in 1900 smaller than the population of Oceania in 2020? And this is one of those indicate all such regions questions, so we might have more than one answer. All right, so just like the last question, I want to minimize the amount of work I have to do here. And so I've taken some information from the question, and I'm going to do a little bit of calculation, as small amount of calculation as I can. Then we'll go back and compare the graphs and get to the answer. All right, so what we could do is figure out the total population of Oceania from 2020, and then we could figure out the total population of all these places in 1900 and compare the two numbers. Now that's going to take a lot of work. I'm going to have to do, well, one calculation here, at least 2, 3, 4, 5, 6, 7 calculations as a minimum in order to get it. Instead, what I'm going to do is I'm going to figure out the total population of Oceania in 2020, and then figure out what that would be as a percentage of the total population in 1900. And then just like the last question, I can just compare the percentages. I don't have to do any more calculation. All right, so what we could say is in 2020, the population of Oceania was 0.55% of 7.796 billion. And so we could say the 2020 total Oceania population, with a bit of calculation, 0.55% of nearly 8 billion. It comes out to be, if you use your calculator, something like 42.9 million. All right, so then I'm going to take that population and say, what is that as a percentage of the total population in 1900? So I would do the 42,900,000 divided by 1.524 billion. So I'll do here 42,900,000 divided by 1.5 billion times the answer by 100. That's going to give me a percentage. That percentage turns out to be 2.81%. Now, we'll go back to the graph in a second, but for any region where the percentage on the 1900 graph is smaller than 2.81, then that's one of the answers we're going to want. Right, and so as we said, I'm looking for efficiency here. I've done 2 calculations rather than figuring out the population, the actual population of any of these in 1900, which could end up with me doing 7, maybe more calculations. So I'll put the graphs back up on the screen. And as we said, we're looking to find any any of the regions in 1900 in the left-hand graph where the percentage on the pie chart is less than 2.81%. So just working your way around, that means South America, yes. So we do want South America. So E is going to be one of our answers. The Middle East, also yes, 2.49 is less than 2.81. So D is going to be one of our answers. North America, no, 6.96 is bigger than 2.81. So North America is not going to be one of our answers. Same with Europe, that's too big. Same with Africa, that's too big. And then Oceania, 0.39% is less than 2.81%. So Oceania is going to be one of our answers. So for this question, our answers are going to be D, E, and F. All right, so I hope you're beginning to see that in each of these questions, I'm spending a little bit of time up front to think about what's the best way through the problem so that I can minimize the number of calculations I can do. And if I can, I'd like to be able to estimate. So I'm going to give you one more question on this set of data. This one's going to be a little bit tougher, so give you a little bit more time. I'll see you back here soon. Okay, pause now if you need a little more time to look at this one. Now, this is the most calculation heavy of the 4 questions we're going to do here. So I've taken some of the data, written it up behind me, so we're not going to need the pie charts for this one. So I'm going to take them away so that you can see what's going on up here and we can have a look at this one together. All right, so this question, which of the following is closest to the percentage change in Europe's population from 1900 to 2020? And I've taken the data that we might need. So the total 1900 population, the total 2020 population, and the percentages from both the pie charts for the 1900 and 2020 data. All right, this one, we've managed to get away without much calculation in the previous questions. This one, we're going to have to do a bit of work. So this is one of those, accept it, buckle in, we've got to be efficient. Let's get down to work here. All right, so first of all, let's figure out what the populations were in 1900 and 2020. So Europe's 1900 population is going to be 15.34% of this little over 1.5 billion figure. And that comes out to be, if you get your calculator out, stick that in, that comes out to be 233.78 million. All right, I'm going to leave that as the 233.78 million because I don't really need to worry about the 0.00000 at the end of that. Once we get to the percentage change part of the question, I can just leave that out. And so I can do a similar sort of thing for Europe's 2020 population, and that's going to be 9.59% of nearly 8 billion. And that comes out to be, if we go through the calculations there, that comes out to be 747.64 million. All right, so we know the populations. Now I've got to deal with the percentage change. So the way of doing percentage change, we could put it into new minus old divided by old. And very important here, don't forget to times by 100. All right, so plugging the values in, the new one we want, the change is from 1900 to 2020. So the new one is the 2020 population. The old one is the 1900 population. So in this case, I'm going to do 747.64 minus 233.78, all divided by 233.78. And then I'm not going to forget to times it by 100 there at the end. All right. If you go through all that, you've got a calculator on the GRE, be careful with it. It's very easy if you're under pressure to type in the wrong number if you're trying to go too fast. But if you put all that in, what you're going to get is 219.8%. Now that's the percentage change. So the change in Europe's population, or the percentage change from Europe's population from 1900 to 2020 is about a gain of 219.8%, which is closest to this 220% gain. And so E is going to be our answer. I said it a couple of times in there. If you forgot that times by 100 at the end, you might have got C from the answer choices there. Don't forget the times 100. The answer to this one's going to be E. All right, so that final one, there isn't much we can do about it. We're just going to have to get into the calculations, be as efficient as possible. I've written everything out here so that you can see what's going on. You obviously don't have to write all of this. You don't have to be writing Europe's 2020 population because you're going to know what you mean. Just be careful that you keep your working as clear and as easy to read as possible so that you don't mix yourself up, and then just efficiently work through the problem and you're going to get there. Right. Percentage change often comes up in these data interpretation questions. So it's good to be able to get through that process as quickly and efficiently as you can, because as you can see, it's going to take some time. Rest of the questions, we managed to make them as efficient as possible by minimizing the calculation. We had to do some here. It happens. You've just got to roll with it. All right, so those are the 4 questions I'm going to ask you on that first type of chart. Pie charts, we had percentages. The next one I'm going to get into is a bit more of a bar chart setup. So first question of a new set of data, like we said right at the beginning, treat it like a reading comprehension passage. So I'm going to give you a little bit more time to look at this one. Take the time to read the graph, understand what it's talking about, what it's telling you before you read the first question, have a go at it. Give you a couple of minutes to have a look at this one, and I'll see you back here very soon. Okay, pause here if you need a bit more time to take a look at this one. But for now, we're going to jump in. I'm going to stay small over here at the side of the screen. We're going to take a look at the graph and what it shows. Then we'll get into question one. All right, so bar chart here to begin with, different from the pie charts we've just looked at. In this case, I have 5 cities. So each of the 5 cities are doing a different thing. That's why the bars are separate. And what I've got here is the percentage change in annual subway ridership in 2021, but that's split into 2. So we've got the black bars are the change from January to June for each city, and then the grey bars are the change in July to December for each city. We don't know, ignoring question 1, ignoring the bottom at the moment, we don't know how many subway passengers there were for each city at the start of 2021 or at the end of 2020. And so we don't know how many are at the end. This could all be very different. The cities could have different numbers, all right? So let's get into the question here. We are told there are 450,000 subway passengers per day in City B at the end of 2020, and we want to know how many subway passengers per day there were in City B at the end of 2021. So I've got to make the change represented by the black bar and the change represented by the grey bar for City B across the year that we're looking at. So first 6 months, the black bar tells us that in January to June, City B's ridership went down by 20%. Then the grey bar tells us that the change in July to December is the ridership went up by 20%. So the temptation here is just to go, well, it went down 20% and then up 20%, and so it stays the same, and so that means that C is the answer. Okay, but hold up for just a second. The grey bar, the change in July to December, that tells us the percentage change based on the figure that's from the end of June 2021. It doesn't tell us 20% change on the 450,000 at the start. It's a bit more complicated than that. All right, so what I'm going to do is I'm going to take the graph away. We've got a couple of calculations to do, and I'll show you why the answer to this question is not C, why those 2 bars don't just cancel each other out. So let me pull the question away. We can come back to the graph if we need to, but we're just going to take a look at the problem here. All right, so our start point, we got 450,000 passengers, subway passengers to begin with. So we're starting with 450,000 passengers. Right, now to begin with, the black bar in for City B said that we were going to go down by 20% first. So if I reduce something by 20%, then I actually have 80% of it left. So a reduction of 20% is the same as saying, well, what is 80% of my starting value? So I could say this is like multiplying by 80 over 100. Right? Then I want to go up 20%. So for whatever value, this is January to June, and this is July to December. Whatever value I get at the end of June, then I'm going to go up 20%. Now that value at the end of June is represented by this 450,000 times 80 over 100. So I can just multiply that again. Now going up 20% means that I have 120% of my starting value. And so we're getting into repeated percentage change here. I'm going to do 450,000 times by 80 over 100 times by 120 over 100. Or because this is the GRE and you've got a calculator, 450,000 times 0.8 times 1.2. Now, just as an illustration of why C is not the answer, you don't have to do this if you were doing the question, 0.8 times 1.2, that comes out to be 0.96. And so overall, the change overall for this year for City B is going to be 0.96. It's going to be a slight reduction, right? If you do go and put this into the calculator and figure it out, it comes out to be 432,000. So the answer to this question is going to be B. So this is what you've got to be careful in a question like this with repeated percentage change. You've got to be careful about where the start point for that change is. Right, we said here that this is our start point. First 6 months of the year, yeah, we're taking 80% of that original figure. But the second half of the year, I'm not adding 20% of the original figure. I'm adding 20% onto whatever the figure was at the end of June, which means that overall, I'm not getting back to my start point. I'm actually losing 4% overall, which means that my answer for this question is 432,000. So you've got to be careful with the information that's been given, especially when you're dealing with percentage change. Where does that percentage change, where does that change start from, and where does it stop from? All right, we've got 2 more questions using this set of data, this graph. I'll get the next one up on the screen, give you a little bit less time because you've had a chance to see the data already. I'll see you back here. Okay, pause here if you want a bit more time to take a look at this one. Now, this is another question where we're going to have to do a bit of calculation. So I'm going to get the data from the graph, pull you away from the graph so that we can work on the board together to do this one. All right. So to begin with, we know City C and City D both had 120,000 subway passengers. The number for this part of the question, frankly, doesn't matter that much. So I'm just going to say they had the same number of passengers, and we'll deal with the number later. The point in this question is how much greater was the average number of daily passengers in City D than the average number of daily passengers in City C at the end of 2021. So we're going to have to take that number, the 120,000, and do something similar to what we did in the last question for City B. I need to know the repeated percentage change so that we could find the number of subway passengers at the end of the year for both City C and City D. So I need the percentage changes for City C and City D in order to do my calculations. So taking a look at the bar chart that we've got in front of us here for City C, the black bar is up 15%. So I'm going to have an increase of 15% in the first 6 months. And then in the grey bar, I'm going to have a decrease of 20% in the second half of the year. For City D, I'm going to start the year, the black bar, with a decrease of 20% in the first 6 months. And then in the second half of the year, in the grey bar, I'm going to have an increase of 25%. So I've got those 4 percentage changes. That's the information I need from the graph in order to go do the calculation. So I'm going to pull you away from the graph, get rid of the graph, get the board nice and big so you can see what's going on, and we can begin finish this question off. All right, so I've taken that data there. City C up 15%, then down 20. City D down 20, then up 25. And now we just need to do a very similar calculation to the calculation we did in the last question. For City C, I'm going to start with 120,000. Now, to go up 15%, I would multiply that by 115 over 100, or multiply that by 1.15. And for City D, I'm going to go down 20%. So that would be the same as multiplying by 0.8. Now, if I go through all of that, that's going to leave me with 110,400. And this 120,000 times 1.15 times 0.8, put it into the calculator, be careful with what you're doing, but be efficient. Let's get an answer. City D, very similar. I'm going to start with 120,000. I'm going to go down 20%, so multiply by 0.8, up 25%, so multiply by 1.25, and that's going to leave me with 120,000. I'm back to where I started. City D is back to the same point. If you go down by 20%, up by 25, you get back to where you started from. All right, so the question that we were asked was how much greater was the average number of daily passengers in City D than the average number of daily passengers in City C at the end of 2021? In other words, what's the difference between these two numbers? So all I've got to do to finish this question off is to do 120,000 minus 110,400, which gives me 9,600, which means that the answer to this question is going to be D. So once you get the hang of these repeated percentage changes, some of these questions, although it looks like there's quite a lot of work, they can fall out relatively quickly. You just got to be careful with the data you're taking, make sure that you're reading the graphs very precisely, and then you can get through the calculations. All right, I've got one more question for you on this set of data. Again, this one's going to be a little bit harder, so let's see how this goes. I'll give you a couple of minutes. We'll see you back here very soon. All right, for the final time for this set of data, if you need any more time to have a look at this question, now's your chance to pause the video, but we're going to start looking at the problem here. All right, so this question, it starts out, again, it's another one that starts out by giving us a number of subway passengers. The number itself, not particularly important at this point, but I'm going to come back to it. I'm going to pay attention to it and come back to it. Really, the big bit that I want to pay attention to at the moment is this middle sentence. So if City A and City E had the same number of subway passengers per day at the end of 2021, which of the following is closest to the number of subway passengers per day that City E had at the end of 2020? So what I'm going to have to do in this question is take that 120,000 at the beginning, work forwards through City A, so make the changes that City A has going forwards, get the number of subway passengers City A has at the end of 2021. That'll be the same as City E, and then I'm going to work backwards to get to the end of 2020 for City E, and that's going to be our answer. So in order to answer this question, I'm going to need to take away the percentage changes like we've done for the other questions in this graph. So we're going to take them away, then we can get rid of the graph, and we can work together on the board to find the answer here. So City A, first of all, the black bar, the first 6 months of the year, that's going to go down 10%. And then the grey bar, it's not the easiest to read, but it looks like it's about halfway between the 12 and the 14 line. So I'm going to say it's going up 13%. All right, City E, the first half of the year, the black bar tells us that the ridership went up 20%. And then the second half of the year, again, being very careful because it's not on one of the big lines, but City E in the second half of the year, the ridership went down by 18%. So I've got that data written up behind me so that we don't need anything more from the graphs. So I'm going to get rid of the graphs for now, and then we'll go through the question together on the board. So let me pull this away, and we can get into this problem. So like I said, the order that we're going to do this in is we're going to go forwards through City A. So we're going to take that 120,000 that we started with, and then I'm going to say we're going to go down 10%, so that would be multiplied by 0.9, and then up 13%, so I'd multiply that by 1.13. Now I've got my trusty calculator here. You've obviously got the one that you'd have on the GRE on the screen. So 120,000 times 0.9 times 1.13 will give us a value of 122,040. Now, this is the challenging bit here. What I can say for City E is I've got some unknown value to start with. Now, for that unknown value, we're going to go down 20%. So I would multiply that by 0.8. Sorry, up 20%. So I would multiply that by 1.2. And then down 18%. So I would multiply that by 0.82. And that would give me the same as City A. So I would end up with 122,040. So in order to find this unknown value, I need to take that 122,040 and then divide it by 0.82 and then divide it by 1.2. And that case is going to give me my unknown starting point for E is going to give me 124,024. Now, this question says, which of the following is closest to? So it's not going to be a precise answer, but looking at the values here, 124,024, I'm 24 people away from C. And so the answer to this question is going to be C. So this question, quite intimidating, huge, great long piece of text, but that's why take a bit of time, understand exactly what the problem's asking you to do. In this case, it was work forward in time for A and then work backward in time for City E. We know that at the end of 2020, the start of 2021, City E had 124,024 passengers. That's closest to 124,000. So that's going to be our answer. All right, so as you can see, the problems in this set of data were all very similar, but it was more about interpreting the question, taking the information you need, being very careful with how you read the graph, and then being efficient with the calculations. All right, we've got one more set of data for you, 3 more questions to go. This one, often people don't like these sorts of questions. This is one with a big table. So like we've done with this question, with a lot of writing here, please don't get blinded by it. Don't just shut down. Take your time. First question, treat it like a reading comprehension passage. Have a look at the table first. What does it show you before you worry about question 1? Then you can get into question 1, hopefully with a good understanding of the data. And once you've got that understanding, these questions aren't that hard. All right, so like we've done before, first question, I'm going to give you a bit more time to take a look at this one. I'll see you back here in a couple of minutes to look through the problem. All right, I hope that's been enough time to take a look at this question. This time I'm not going to take the question away because there's actually not that much working to do here. First question on this new set of data, so we'll spend a bit of time talking about that before we actually look at the problem. Now, with big tables like this, when you see a huge, great wall of data, a lot of people just freeze up. There's too much to take in, and in something like this, I probably don't want you spending too much time looking down each line, looking at what you've been given. We're going to pick out the bit of the table, the bit of the data we need just by looking at the question. So this question says, which region has the median number? Okay, we're looking for the median, we're looking for the middle number in a set, but I'm going to put that to one side for a second. We'll come back to it. The median number of secondary education teachers. Now, if I look at the table, we've got split it into two halves, the left-hand side, the right-hand side. Left-hand side just talks about the number of students enrolled in these places, primary, secondary, tertiary education, but it's just about the number of students. So I can put the whole of the left-hand side of the table to one side for now, because this question is just talking about the teachers. So if we're looking at the right-hand part of the table, we've got primary, secondary, and tertiary education. And the question is asking is for the secondary education teachers. So in that right-hand block, the only bit I need to look at is the middle column. And now this question's gone from looking at a whole huge table to just one column. And all we need to do is focus on that one column. And hopefully this question is not too difficult. And like I say, you don't have to think about freezing up when you see something this big and this intimidating, to be honest. All right, so to get into this question, all we're asked to do here is find the median number of secondary education teachers. As I say, I'm looking down that secondary education column for the teachers, that fifth column as we look from left to right on the screen. Now there's 9 entries there, so the median one will be the fifth biggest number as I go from smallest to biggest. So if I read down that column, the smallest number in that list is Northern Africa, that top row, so 993. Then the next biggest is Sub-Saharan Africa, second row down, 1,172. Then, if we keep increasing in size, the second from the bottom, Western Asia, 1,340. Then back up to the top again, third row down, North America, 1,774. And finally, near the middle, Southeastern Asia has 2,203 teachers. Southeastern Asia is in the middle. It is the fifth entry as we count from smallest to biggest. So Southeastern Asia will be the region that has the median number of secondary education teachers. So D is the answer here. So in a question like this, as I hope you can see, a big chunk of the difficulty comes in not being intimidated by how much data you're being given. If you can strip away the bits you don't need by reading the question really carefully and just identifying the part of the table you do need, the question should end up looking a bit easier in your eyes once you really dig into the details. And as you can see, once we got into the question, it was just a case of listing the numbers from smallest to biggest. All right, we're going to make the questions a little bit harder when we're looking at this table now. So I'll get the next one up on the screen. As usual, we'll give you a bit of time and we'll come back to see you to go through the solutions soon. All right, now's the chance to pause it if you want more time for this one. But let's take a look at this question together. All right, so very similar problem A very similar starting point to the problem as the last question. I just need to extract the data, then we're going to go do something with it. So we're asked, the number of teachers in secondary education was approximately how many times greater in Southeastern Asia than in Western Asia. So I need to know, in order to do this question, the number of teachers in secondary education in Southeastern Asia and the number of teachers in secondary education in Western Asia. So in this question, we're back to looking at that fifth column along as we look from left to right. Secondary education, number of teachers. Now, the number in Southeastern Asia is 2,203, and the number of teachers in Western Asia is 1,340. So I've taken that data out. We've got that up on the board here, so we can remove ourselves from the table, get the information we need, get out, and now we can finish the question off. All right, so the question was that, the number of teachers in secondary education was approximately how many times greater in Southeastern Asia than in Western Asia. So I need to know, what would I multiply 1,340 by to get 2,203? Or in other words, 1,340 times by some number is going to be 2,203, and that's going to give us our multiple, how many times greater. So this multiple is going to be 2,203 divided by 1,340. And if you put that into your calculator, you're going to get something approximately 1.644. Now, looking at our answer choices, 3/5 and 2/3 are less than 1. This is about 1.5. For 1.5 is about 1. It is 1.5. 1 and 2/3 is about 1.666, and 3 is going to be too big. 1.644 is definitely closest to 1.666 out of the options we've got. So D is going to be our answer to this question. So as I'm hoping you see it, as the difficulty increases in how hard it is to extract the information from the data, from the table, from the graph, from whatever they give you. So extracting the information is more fiddly in this set of examples compared to the previous two. Well, then the questions get easier, or relatively easier, because the difficulty here is getting the information out of the problem. So like we've said all along, if you treat it like a reading comprehension passage, take a good look at the question, or take a good look at the information, take a good look at the data, understand what it's saying, we've got through this problem relatively quickly. All right, I've got one more problem for you today. Again, third one for this set of data, so I'm going to step the difficulty level up slightly. Take your time, be careful with reading the table, and you should be okay. So I'll see you back here in a little bit for the final time today. All right, for the final time today, if you need a little more time to take a look at this question, now's your chance to pause it before we go through it. All right, so this one, there's quite a lot more to this one. I said it was the hardest one for this table, and so we've got a bit of thinking to do. So that, first of all, let's extract the data, then we can get rid of the table, we can start working together on the board. So the question is, for which of the following regions is the ratio of students in tertiary education to students enrolled in primary education smallest? So I need quite a bit of data for this one. All right, and so I've pulled it out and I've written all the data up here, but in this case, this is one where I might not write things down until I have to. So what I've done is I've taken the tertiary education, third column as we work left to right, and the primary education, the first column as I move left to right, and taken the number of students in each of those places. So I've written the data up here. Let me pull you away from the table. We can come back to it if we need, but easier to talk the problem through here and explain why I might not write all of the stuff down. Right, so I'm going to look at the question first, and what we're asked for is which of the following regions is the ratio of students in tertiary education to the students enrolled in primary education the smallest. So what that means is in order to find the ratio, I would take the number in tertiary education, divide it by the number in primary education, and I'm looking for what would make that number as small as possible. So in other words, I want the primary education to be as big as possible compared to the tertiary education. Right. And so if I take a look at Northern Africa first, well, that 7884, that's kind of about 8,000. And primary education, that's kind of about 30,000. And so I could say that the primary education is about, it's slightly more than 3.5 times what's in the tertiary education. And so my correct answer, or if any of the others are going to be the correct answer and not Northern Africa, then the number of students in primary education needs to be about 3.5 times, or maybe more, times the number in tertiary education. So as an example, if I look at Latin America and the Caribbean, yeah, 64,000 is greater than 26,000, but only by 2.5 times. Right, I can look at that, I can approximate, I can estimate, and so I don't need to worry about Latin America and the Caribbean. That can't be my answer. So I probably wouldn't write if I was doing this myself in the exam, I wouldn't write this data down. I'd be able to look at those two, having looked at Northern Africa and know that's 3.5 times. I could look at Latin America and the Caribbean, look at those numbers, go, that's 2.5 times. It's smaller, it's out. Don't need to write those down. Don't need to worry about them. Similar thing in Eastern Asia. 44,000, maybe 45,000 times by 2 is going to get me to 90,000. Times by 3 is going to get me to 135,000. So yeah, this is about another one, about 2.5 times bigger. It's not as good as 3.5 times. Don't need to write the numbers down for Eastern Asia. We can leave those out. Southeastern Asia, that's about 20,000. That's getting on for 70,000. So that's another one. That's about 3.5 times. So I would write down the information from Southeastern Asia, and then from Europe, that's less than 2 times. So I wouldn't write those down. So if we go back to the table, if I just put that back in here, there are, I've got up on their board 10 pieces of information, 10 numbers. But I could have just worked my way down that table and gone, again, let's go back to Latin America and the Caribbean, 26,124 versus 64,349. That's about 2.5 times. Northern Africa has already beaten it. Don't write it down. And so for what I would actually write in order to do the problem, I'm going to write down 4 numbers. I'm going to write down the numbers for Northern Africa. I'm going to write down the numbers from Southeastern Asia. And I'm going to rule out B, C, and E from this question. They can't be the answer. All right, so let me take the table away and we'll finish this problem off. At this point, I've got my 4 numbers written down. I've got my Northern Africa and I've got my Southeastern Asian numbers written down. And I'm going to go and calculate the ratio. So if I get my calculator out and do 7,884 divided by 29,351, that's going to give me a ratio of 0.27. And then if I do the same for Southeastern Asia, that's going to give me a ratio of 0.29. Because I want this ratio to be for which the ratio is ratio of the student to tertiary education, I want the smallest ratio possible. 0.27 is less than 0.29, so the answer to this question is going to be A. Okay, so I know I wrote down all 10 pieces of information in order to show you how I would go about doing this question, but realistically, if I was in the exam, I wouldn't write down the numbers for Latin America and the Caribbean, for Eastern Asia, or for Europe. I would write down 4 numbers, the ones for Northern Africa and Southeastern Asia, and those are the only ones that I would calculate the ratios for. The rest of this is just an estimation game. I want this number to be as big as possible compared to that one. These 2 ratios, 0.27 to 0.29, that's too close for me to estimate, but I can reduce the amount of work I've got to do fairly significantly. And that's the problem in a microcosm for these data interpretation problems. Like we said throughout, treat them like a reading comprehension problem. Read the data before you read that first question. Understand what kind of picture you're being given. You can get a relatively good idea of what you might be asked, and then be very careful with extracting the data you need and have a think about how you're going to answer the problem so that you can reduce the amount of work so that you can be as efficient as possible. I don't want to be typing all 5 calculations into my calculator to figure out the ratio for these other options when there's no way they're going to be the answer. That's work that I don't have to do. I can be more efficient than that. And by following that process, I have the time to be more accurate with the work that I do. All right, I hope that's helped on the data interpretation questions, and we look forward to seeing you back here for another one of our videos very soon. Thank you very much, everybody. Have a great day.